we begin by asking, what is the nature of space and time? So although 20th century theoretical physics has opened important perspectives in the exploration of new territories, such as the meaning of matter at the Planck scale and the role of quantum information, to name a few, it is characterized by significant foundational problems, which the inner unity of physics knowledge depends on. In particular, the most relevant foundational problems regard the arena of the universe and its geometry. This is the most basic level. We need to get that right. In the light of the developments of theoretical physics in the fields of special relativity, general relativity, quantum theory, the following questions become natural. What must be considered the real fundamental arena of physical processes? What is the real background of physics? What is space? What is time? What is the geometry that rules physical processes? What is the meaning of moving? For instance, what do we mean by the speed of light? What is that? How does that come about? That's something we'll look at. These are some of the foundational questions that one must face in order to find a novel synthesis of the world and to find a new unified foundation of science. I really believe that space itself is the foundational principle where we can get to a unified science. It's kind of a remarkable thing because we begin our exploration with perhaps the most fundamental element of the physical universe, space. And while classically space has been characterized with these kind of vague notions of being like the primary arena in which physical processes of the universe unfold, so much like a stage with the dance of cosmic actors and particles taking place on its surface, but having no real interaction or role in that unfolding drama. So it's an inert stage. It can be argued that the most significant developments in physics has been the understanding that space is not empty. Space is not inert. And physics has kind of gone back and forth on this over the last 100 years or more. Because we have the 19th century notions of the luminiferous ether. From that, we get the idea that there is this substance to space, this energy of space, but we also see that the geometrization of space from general relativity, so space has structure and geometry, and from quantum field theory, we get the picture, the discovery that space may have a atomistic or quantized structure. This is oftentimes likened to space is made of all these entangled bits, these qubits, these entangled bits of information, and it's how they relate to each other that gives you some of the phenomenal properties that are observed in the universe. So here we've got general relativity on one hand and quantum field theory on the other, and bestowing an attribute of substance, energy, and geometry. So our understanding of nothing has evolved. In this way, space begins to become a dynamical element shaping and ordering the evolution and development of physical systems, their characteristics and properties. So we begin our investigation into the big questions or our hard problems of science course from the 0 point, from nothing. And so for those of you who've already registered for the course, I hope you're not having second thoughts hearing that this course is going to be fundamentally about nothing. So we're going to be starting from an investigation of the nature of nothing, but as we'll see, the concept of nothing is, in fact, a ontological impossibility. So this is one of the most impactful statements, I believe, that comes from Charles Misner and John Archibald Wheeler, as in their paper where they begin to introduce the idea of quantum geometrodynamics, something that we're going to be getting into. And you'll probably, for those of you taking the course, you'll see this quite a bit because I don't think it can be stressed enough. There's nothing in the world except empty curved space. Matter, charge, electromagnetism, and other fields are only manifestation of the bending of space. Physics is geometry. So this is a key concept. John Archibald Wheeler was also famous for extending that it's not only geometry, but it's information. It from bit is something he's famous for saying. Following the progression of scientific theory regarding the ontological nature of the physical world, or primary or ontological primaries or first principles, which is inevitably leading to theory unified by a connective worldview perspective, because it can go no other way. We get to perhaps one of the greatest factors connecting all things together, and that is space. Because space is the one thing connecting all things, it forms the foundation from which a unification of physics theory and science itself, science in its entirety, can be realized. A unified perspective or narrative across all science. Space is an interesting component to use as the foundation of a unified science because classically space is considered to be empty, devoid of substance. The term space as defined is usually something devoid of substance, structure, energy, etc. It's a term we conventionally use to refer to a body of nothing. This nothingness is what separates objects. And I open up the introduction of the written material, giving trying to give like an analogy of the perspective of this idea of space separating objects, and how that is a part of our like common sense experience. And so it gives us the idea that things are separate because we don't necessarily see the underlying structure. And I kind of run with the analogy of like when we first started the scientific delineation of the nature of air, of the atmosphere, back in the 18th, 17th, and 18th centuries. So, it begins to show us that our common sense perspectives are not always correct, and that our senses can be misleading. But so if this nothingness is what separates objects, giving material bodies a definitive location in space, and thus allowing them to exist as distinct objects, shouldn't physics be focused on the objects instead of their background arena of space, which is fundamentally a vacuum and therefore nothing? Well, as 20th century science has advanced, it has become a irrevocable fact that a true vacuum cannot exist, that even seemingly empty space is full of oscillating fields, phantom particles, geometrical structure. And from an ontological perspective, this should have been obvious from the beginning because nothing, by definition, does not exist. Space exists, so it can't be nothing. It's a little bit of philosophy or metaphysics there. So just a quick note on what the father of electromagnetism had to say about this. James Clerk Maxwell, who was one of the first to develop, well, he was the first to develop a successful unified field theory. And this is his thoughts on the nature of space. There can be no doubt that the interplanetary and interstellar spaces are not empty, but are occupied by a material substance or body, which is certainly the largest and probably most uniform body of which we have any knowledge. So I think that's a profound statement. And of course, in his time, this was referred to as the luminiferous ether.